Hello, hey, fourth and fifth graders, listen up. We're gonna talk about some things in math, and because your lessons parallel each other pretty closely, it's good for both of you to watch this, fourth graders and fifth graders. I'll probably try and group your lessons together like that. And just a little something on a side note here. If any of this stuff is really confusing for you, don't be afraid to go to like the Khan Academy or just go and Google it on the internet and watch some videos that might help re-solidify some of this information so that you learn it really well. What I want to talk about today, we're going to go through actually 3 different lessons and just touch on the highlights of it. We're going to talk about lines, rays, and angles. We're going to learn how to classify angles. And then we're going to talk about parallel lines and perpendicular lines. Now, we all should know what those things mean. If you watched the vocabulary video that I uploaded, but we know a line looks like this, and it can go as far as you want in any direction. A ray is a point that moves in a direction, but it only goes in one direction. And of course, an angle is an angle. An angle can be anything within the 360 degrees of a circle. Classifying the angles, basically we'll be talking about acute and obtuse angles and lines. Either lines run parallel and never touch, never cross, or they cross perpendicular. Perpendicular means they cross at a 90-degree angle. So this is pretty good stuff for you to follow. Let's talk first about how you notate these things in math. We're going to talk about the line. So if you're going to have an example of a line, and we're going to make 2 points on that line. And by the way, I'm in the 4th grade book right now on page 549. It's lesson chapter 10. So this is 10.1. We'll make a couple of notations here to define this line. And we're going to give it a title of B and C. So you have a line. That line is referred to as BC line. How would you notate that mathematically? You make a little line, and then you put BC. And that tells you it's a line. Not a ray, not an angle, but a line. This is the symbol for line. And BC defines what that line is. Now, if we take that same example, well, I tell you, I just about knocked the whole whiteboard over. Now I've turned that into a ray. It starts at point B, and it goes to point C. This is a ray. Goes in one direction. How would I notate that mathematically? Well, you use the same symbol. And then, of course, it's defined BC. That's pretty easy, huh? Now, you don't necessarily have to put a comma in there. You can just write the 2 letters of the 2 points defining that ray. Now, what if we turn that into a line segment? Now, a line segment is 2 points located within a line. Here's our line going off into both directions, but we're only concerned about this segment of the line. So now how would we notate a line segment? Well, it's just as simple. That's the symbol for a line segment. And then notate its reference points. So that's all there is to that. Let's see what else is in here. Angles. An angle is formed when two rays come together. There's one ray. There's another ray. This is called the vertex. It's the point where those two rays come together. The angle is then defined by degrees, indicating the spread of those two rays. And for example, if your rays are moving at a right angle, then the degrees of that angle would be 90. So you've got two rays, they come together at the vertex, forms an angle. These, well, this is a right angle. This is an acute angle. Now, if that angle, if your rays look like that, this is obtuse. And basically what it's saying is, an acute angle is any angle that is less than 90 degrees, but more than 0 degrees. An obtuse angle is any angle that is greater than 90 degrees. And a right angle is at exactly 90 degrees. Now, the only thing missing from this description is a straight angle. A straight angle is always 180 degrees. And I know I've explained that in the past because on a circle, it goes from 0 to 360. There are 360 degrees around the circle. Halfway, each half is 180. Together, they equal 360. So that straight angle is 180 degrees. If we want a right angle, that's 90 degrees. You understand? So, when you look at the circle, let me erase this because I think if I draw a bigger picture of that, it'll be easier for you to understand. If you're looking at a circle, and it starts at 0, goes this way, all the way around, it continues all the way around. When it gets back up here, it has gone 360 degrees. So if you move around this circle, let's make a point in the middle here, that's our vertex. If you go 1/4 of the way around here, you've gone 90 degrees because 360 divided by 4 is 90. So that's a 90-degree angle. It's always indicated by a little box in the corner. That way you know it's a right angle. If you go further, if you go from here and you go all the way to here, in other words, you've gone from here to here, you've gone, see the straight line? You've gone 180 degrees. Now, if you go, let's say you go from here to a point right here. This angle is less than 90 degrees, and that makes it acute. It's more than 0, but it's less than 90. Once it hits 90, then it's a right angle. When it goes beyond 90, that angle then is obtuse. And an obtuse angle is greater than 90 degrees, and it'll be an obtuse angle all the way until it gets to here. Then it becomes a straight angle, and it can continue around. If this is your angle, this angle here, you have an angle here, and then you have an angle here. Both of those angles together are going to equal 360 degrees. So, this is an obtuse angle. Once it gets here, then it's a right angle. And when it's coming in this direction now, because you can go either way. It goes 0 to 360 this way. It also goes 0 to 360 this way. The only thing that's important to understand is that there are 360 degrees around the circumference of that circle. Within it can be any number of different angles. Some of them will be less than 90 degrees. Some of them will be more. If they're less, they're acute. If they're more, they're obtuse. The easy way to do is always compare your angle to a 90-degree angle. If you know what a 90-degree angle is, which is your right angle, that's a 90-degree angle, and they give you an angle that looks like this, or they give you an angle that looks like that, you can see that this makes that obtuse, and you can see that this makes that acute. So compare it to a right angle, and you'll always be able to tell if it's wider than 90 or if it's less than 90. That defines those two angles. You probably don't think about it, but if you looked at a map of the city, a street map, you would see all the streets in the city. And let's just say one particular area has streets that cross like this. Now these streets, of course, they go on in their directions just like that. And we can identify using alphabet letters. And let's just do that. Well, let's make some points here. This one's A. This point here is B. This point down here is J. We got a point up here, we'll call it K. And then we have a point here we'll call P. A point here we'll call R. A point down here we'll call Q. And then the last point over here we'll call C. Now, this could be a road map in any city. Within this map, you see a whole variety of different things. First of all, the first thing that jumps out to me is this road here, road PQ, crosses road AC at a right angle. And because it crosses it at an exact 90-degree right angle, it crosses it perpendicular. Perpendicular means it crosses another line at 90 degrees. Now, I see no lines that run parallel. But if we had another road in here, just randomly put another road in here and call this one RS. So this road here is running parallel to this road here. So I could say that road RS runs parallel to road AC. Now, if you look at these different points, remember, angles are formed where lines cross. So we have an angle here. We also have an angle here, an angle here, and an angle here. We know this is a right angle because it's at 90 degrees. So that's a right angle, and that's a little box that you'll see when there's a right angle. But these two angles represent this angle here is less than, if it was 90, it would be like that. So this is less than 90 degrees. So that's an acute angle. And because this angle here is greater than 90 degrees, that's an obtuse angle. Are there any rays within this chart of lines? Well, yes, there is. There's a ray that runs from here to here. So BA would be a ray. So you would write your ray symbol and then BA. This is also a ray. So you have a ray that runs from B to J. And you have a ray that runs from B to K, as well as R to P and R to Q, and from R to C. Each one of those continues, but only in one direction. Ray BK only runs from this intersection in that direction. Now, interestingly enough, if this road continued on in that direction, as well as this one, guess what? They would also have an intersect. An intersect is where two lines cross. So you see, this is not rocket science. This is pretty easy to understand. What else do we got going on here? Well, in lesson 10.2 of the 4th grade math book, they give you a whole bunch of examples, pictures of these angles. And they're using triangles. What's a triangle? It's a three-sided object, right? They're using triangles to illustrate how you determine how you classify the triangle. Let's just draw some pictures here. And they label these. So if we label them A, B, C. Now, we're labeling these at the vertex where the lines come together. This one here we'll call E, D, and F. This one here we'll call G, H, and J. And the last one will be L, M, N. This is pretty standard practice, Because when you label them, then you can make reference and people know exactly what part of that, what perhaps angle you're looking at based on the reference. So angles A and C, in this one here, these two angles, angle A and angle C, those are less than 90 degrees. So what kind of an angle is that? If it's less than 90 degrees, it's an acute angle. But if you look at angle B is greater than 90 degrees, so that would be obtuse. Now, looking at this triangle, this is what we would call a right triangle because it's at 90 degrees, a right angle. And because it's a triangle, we just simply call it a right triangle. If we look at this triangle here, all three of these angles, all three of them are less than 90 degrees. So all three of them are acute. Looking at this final example, we have angle less than 90 degrees, angle less than 90 degrees, and angle greater than 90 degrees. So we got two acute and one obtuse angle. Parallel lines and perpendicular lines. When you ask what does perpendicular mean, well, people get confused because they don't know what that means exactly. When you think of parallel, most people understand that things that are parallel, they run side by side. In math, it means just that. Parallel, it means these lines will run as far as they can run, and they never will touch. They'll never bump into each other, they'll never cross each other, and they'll keep the same distance that they're separated for as far as they go. Perpendicular means that it crosses right at a 90-degree angle. It's got to be a right angle for it to be perpendicular. If it looks like that, it's not perpendicular. This is perpendicular. So perpendicular means it crosses at 90 degrees. Parallel means they never cross. Let's see what kind of good examples they have in the book here. Maybe we'll find a problem and see what it's asking us to do. They build a series of lines here, and you have this one, and then you have two lines like this, and then you've got one that crosses like that, and of course they label all of these. But looking at this without any labels, it's easy to see that two of these lines are parallel. Now, if you look closer at it, you see this line and this line, they cross at 90 degrees. So these two lines are perpendicular. These two lines or parallel. And that's pretty much all there is to it. Now, when you label the points, then you can write it out mathematically. You have A, B, C, D. Line AB is parallel to line CD. Pretty simple stuff. Look in your textbooks, review the information, do the practice homework. If you have any real serious questions, let your teacher know, and I can work them out for you. I can put up a short video of any of the lessons, any of the problems within the lesson that may be giving you a hard time. But don't sell yourself short. You can find the answer. Learn how to be a lifelong learner. Learn how to find answers to questions you don't understand by searching for those answers. Meanwhile, stay safe, stay out of trouble, have a good day. I'll talk to you again soon.